The infamous and iconic toadstool, also known as Amanita Muscaria, has received much attention recently as a rekindle of the lost wisdom. There are many YouTube videos which describe this mushroom from historical, cultural, potential medicinal, or even legendary background. However, few videos discuss the chemistry of this mushroom. In the first episode of this trilogy, I would like to discuss the detailed chemistry of the active compound of this mushroom. In the northeast of the United States, this mushroom is yellow-colored and the scientific name is called Amanita Muscaria gassoi, which is a variation. In New Jersey, as far as I observed, this mushroom spawns twice in a year, in spring or in autumn. They love pine trees and deposit white spore print. For detailed discussion of the mushroom, you can find the content in YouTube channels such as, but not limited to, Amanita Dreamer, Fresh Cap Mushrooms, Learn Your Land, Mushroom Wonderland, Stone-Aged Man, Paul Stamets, Fascinated by Fungi, etc. It is important to mention that the active compound ibotenic acid in Amanita muscaria can also be found in other Amanita mushrooms, such as Amanita pancerina, which has a high distribution in the west coast of the United States, and Amanita regalis, widespread in European continent. Now, let's get into the business. Here is the structure of ibotenic acid. The scientific name is S2-amino-2,3-hydroxyl-isoxazole 5-eo-acetic acid. It is, as a matter of fact, an alpha amino acid, as you can already see the evidence from the scientific name. For comparison purpose, in order to help you to understand better, the simplest amino acid in our body is a glycine, also called aminoacetic acid, which is shown here. These two molecules share some similar structures, isn't it? The amine group, symboled as NH2, and the carboxylic acid group, symboled as COOH, are attached to the same carbon atom, which is highlighted by red dots. And when both groups attach to the same carbon, it is an alpha amino acid. The other structural components of this compound are isoxazoline ring and the hydroxyl group, as indicated by the circles. All these components are reflected in the scientific name of ibotenic acid. And now we see the structure of derivative compound muscimol. Both of ibotenic acid and muscimol coexist in this mushroom with a much higher concentration of ibotenic acid. Muscimol is almost negligible. Both of these compounds are psychoactive. Ibotenic acid is more prone to cause neural damage, proved by lots of research. However, muscimol is much less toxic than ibotenic acid. There are many ways to convert ibotenic acid to muscimol. The following is one of the most possible reaction mechanisms happening in an acidic, aqueous environment. Ibotenic acid is a starting substrate, and we can rewrite the carboxylic acid in a different way. First, oxygen in the water molecule attacks the hydrogen on the ibotenic acid to form a carboxylate, a resonant structure. Upon heat, the molecule undergoes a decarboxylation and releases carbon dioxide into the air and results in carbanion. This carbanion is extremely unstable and reactive. As hungry as it is, it takes a hydrogen atom relentlessly from the hydronium, which is an acidic form of water, and results in the final product, muscimol. Of course, there are other side reactions which generates byproducts, but that is not the focus here. This reaction can also happen in a basic environment. However, based on the literature reports, the conversion to muscimol is nearly not happening, and it is poorly understood. It is worth mentioning that you may see other molecular structures of ibotenic acid and muscimol as shown here. These compounds are the same, and they coexisted due to the interconversion of molecules, also known as tautomerization. You can refer to Wikipedia for more information on this topic. We just mentioned about the conversion, so in what condition the ibotenic acid will have a decent conversion rate to muscimol? How to induce this chemical reaction in an ambient environment? It will be covered in the following episode, and please stay tuned. Finally, I have to say a big thank you for Dr. Shashi Ponnana's advice. Dr. Ponnana is currently a leading scientist in a pharmaceutical company which focuses on cutting-edge technology and novel science to treat cancer. If you like this video, please click the like button and subscribe. Your support will help to spread the knowledge of mushrooms and maybe to inspire people to build a better world. Thank you very much for watching. See you next time.